Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. Dear students, welcome you all in Pakistan International School Taif Virtual Learning System. Today is our 18th video lecture for second year students, boys and girls. I'm Mrs. Rosia Imran, your mathematics teacher. Chapter number 2 we already started, and exercise 2.1, 2 and 2.3 we already done, and in exercise 2.4 I discussed question number 1 and 2 all parts with you. Today inshallah I'll start question number 3. In question number 3 we have find dy by dx of the following parametric function. You have given parametric function. If you check in the first part, you have given x equal to theta plus 1 over theta and y equal to theta plus 1. If you check, we have three variables involved, x, theta and y. So means that to find dy by dx, we apply chain rule. How? Look at the first part. We have given x theta plus 1 over theta. To make it in form of power, we take this theta in the numerator, it will be power minus 1. Now you know that two variables is involved in the first equation, x and theta. So we differentiate with respect to x with respect to theta. We differentiate this x with respect to theta because the variable involved is theta. So dx by d theta and d by d theta, theta plus theta power minus 1. You know, when we apply the derivative on the first value, d theta by d theta, we get 1. And when we apply the derivative on the second value, power is minus 1, it will come in the coefficient. So plus minus, minus 1 in the coefficient. And from power, we subtract 1. So minus 1 and minus 1, we get minus 2. To make it positive, we write it 1 minus 1 over theta square. Take the LCM theta square and here theta square minus 1. So we differentiate the first equation with respect to theta, that is dx by d theta. Because if you check, we have to find dy by dx, so means that dx should be in the denominator, so we write its reciprocal. Dx by d theta is equal to theta square minus 1 divided by theta square. When we write the reciprocal, the left hand side reciprocal is d theta by dx and the right hand side reciprocal is theta square divided by theta square minus 1. Now take the second equation. Second equation is y equal to theta plus 1. Again, we differentiate y with respect to theta. So dy by d theta and d by d theta, theta plus 1. So when we take the derivative of theta, we get 1. And when we take the derivative of 1, we get 0. So dy by d theta is 1. Now by chain rule, we have to find dy by dx. So it is equal to dy by d theta and d theta by dx. Why? Because d theta cancel. So again we get dy by dx. So we can write it like this. So this is chain rule. Now put the value of dy by d theta. Value of dy by d theta is 1. So we put it 1. And value of d theta by dx is this one, theta square, theta square. This one d theta by dx is theta square divided by theta square minus 1. So this is the required answer. We solve the parametric equation with respect to theta. Now come to the second part. In second part, if you check, again we have three variables, x, y and t. If you check the second part, x, y and t. These three variables are involved. So again, we differentiate x, the first equation, with respect to t. If you check Here A is considered coefficient constant and the remaining two values are in form of fraction. So we apply quotient rule to differentiate with respect to t. So when we apply quotient rule, A as it is 1 plus t whole square whole square 1 plus t square derivative of the numerator 1 minus t square minus numerator 1 minus t square derivative of the denominator 1 plus t square. So this 1 plus t square as it is, derivative of 1 is 0 and t square is minus 2t. Minus 1 minus t square as it is, derivative of 1 is 0 and derivative of t square is 2t. Now open the bracket, minus 2t multiply, so minus 2t cube, and here minus 2t and plus 2t cube. So minus 2 into t power 3 plus 2 into t power 3 cancel with each other and we get minus 4at divided by 1 plus t square whole square. So dx, if you check, we are going to find dy by dx. So dx in the denominator, so we write its reciprocal. It will be dt over dx and this denominator will come in the numerator, minus 4at in the denominator. Now take the second equation. Again, it's given in form of product. In form of fraction. 2bt divided by 1 plus t. This y is by mistake. Here there is no y. Differentiate with respect to t. So dy by dt. And here for this fraction, we take the quotient rule. So when we apply quotient rule, 1 plus 1 plus t whole square and 1 plus t square as it is, and then derivative of the numerator 2bt and minus 2bt derivative of the denominator 1 plus t square. So this one 1 plus t square as it is, and 2b is treated as coefficient and derivative of t is 1, and minus 2bt as it is, derivative of 1 is 0 and derivative of t square is 2t. Simplify it, 2b plus 2b into t square minus 2 2s are 4, 4bt square. So plus 2bt square minus 4bt square, subtract. So we get 2b minus 2b square. 2b take common, so we get 1 minus t square divided by 1 plus t square whole square. This is value of dy by dt. Now by chain rule, we are going to find dy by dx, which is equal to dy by dt into dt by dx. So dy by dt is equal to this 2b into 1 minus t square divided by 1 plus t square whole square, and dt by dx we already find it. So this 4 and this 2 will cancel with each other and we get minus 2 in the denominator, and here 1 plus t whole square cancel with 1 plus t square whole square. So in the numerator we get b into 1 minus t square and in the denominator 2 into a t and minus sign. So this is the required answer. I hope you will understand it. Question number 3 having two parts, involve three variables and we solve it with the help of chain. Now come to question number 4. In question number 4, again we have given proof that if x is equal to this and y is equal to this. So when proof that means that our question should be, when we solve, our answer should be y into dy by dx plus x equal to 0. If you check this, dy by dx show that first you apply chain by with the help of chain rule, because three variables involved, x, t, and y. When three variables involved, so you can easily solve it with the help of chain rule. So with the help of chain rule, first of all, you find dy by dx just like question number 3. So since x is equal to 1 minus t square, 1 plus t square, so we differentiate with respect to t and we get dx by dt. You do it just like question number 3 and you will get dx by dt this, and when you write its reciprocal, it will be dt over dx is equal to this. Now after that, y is equal to this. Again, you differentiate it and solve it by yourself. So you will get dy by dt is this. Now by chain rule, dy by dx, you know that it is equal to dy by dt into dt by dx. So you put value of dy by dt and dt by dx. So when you simplify it, this one cancel with the numerator 1 plus t square whole square cancel with 1 plus t square whole square, and in 2 cancel with 4. So you get minus 1 minus t square divided by 2 t. This is dy by dx. And now if you check here, y is multiplied with this. So you will multiply y on both sides. So when you multiply y on both sides, here you put the value of y. When you put value of y, 2t cancel with 2t and you get 1 minus t square divided by 1 plus t square. After that, if you check 1 minus t square over 1 plus t square is equal to what? This is equal to x. So you put the value of 1 minus t square, 1 plus t square is equal to x. This is already given in the question, minus x. So when shifted at other side, it will be plus x. And this is the required proof which you want to prove. Now come to the next question, question number 5. Very, very important question, mostly come in paper. You have to differentiate x square minus 1 over x square with respect to x4. Suppose y is equal to x square minus 1 over x square and u is equal to x power 4. Here you have two values. One is x square minus 1 over x square and the second one is x4. So this one you differentiate with respect to x4. So you suppose that this is equal to y and x power 4 is equal to u. So first you differentiate y with respect to x. So when you differentiate y with respect to x, you will get x square derivative is 2x and x power minus 2 derivative is plus 2x power minus 3. So to take common, you will get x plus 1 over x cube and take the LCM, so you get x cube in the denominator and x power 4 plus 1. Now you differentiate this u with respect to x. So du by dx, so d by dx, x power 4. So 4x cube you get. Now by chain rule, dy by du, because y and u are the two equations. So dy by du is dy by dx and dx by du. So dx by du, so you write its reciprocal. So it will be dy by dx is equal to this and du by dx is equal to 1 over 4x cube. 4 and 2 cancel with each other. So you get x power 4 plus 1 divided by 2x power 6. Come to the second part. In second part, you have given that 1 plus 1 plus x square power n with respect to x square. So you suppose this value is equal to y and the second value is equal to u, and after that you solve it. This is equal to y and this is u. Now this one differentiate with respect to x. So dy by dx and power will come in the coefficient, and from power we subtract 1 and then further derivative without power 1 plus x square. So n into 1 plus x square power n minus 1 and further derivative of 1 is 0 and x square is 2x. So this 2x multiply with n, we get 2nx into 1 plus x square power n minus 1. Now you differentiate this one, du with respect to x, so du by dx, which is equal to 2x. So you want dx by du, so you write its reciprocal 1 over 2x. Now by chain rule, du dy by du is dy by dx, which is into dx by du. Now you put value in these two. So this is 2nx into 1 plus x square and minus 1, and this is 1 over 2x. So 2x and 2x cancel, and you get in n into 1 plus x square power n minus 1. Come to the third part. In third part, you have given that differentiate this x square plus 1 over x square minus 1 with respect to x minus 1 x plus 1. So you suppose this is equal to y and this is equal to u. Both are given in form of fraction. So for both value, you will apply quotient rule. So y equal to this and u equal to this. The first differentiate y with respect to x. So you will get dy by dx. Solve it by yourself. Quotient rule. You know that the denominator square, and in the numerator, denominator value, derivative of the numerator minus numerator value, derivative of the denominator. So when you solve, you get this value. And similarly, differentiate u with respect to x. Again, you apply the quotient rule and solve it, and you will get this value. Then after that, you apply chain rule and you will get the required answer. Next, if you check the fourth part, this is just like third parts. You solve it by yourself. Now come to the last part, fifth part. Y is x square plus 1. We suppose it. Let y is equal to this and u is equal to this. Again, we differentiate with respect to x just like part number 3. So you do it by yourself. You will get this value. And then you differentiate u with respect to x. You will get this value. Now by chain rule, you put value and simplify it, so you get the required answer. So this was the last part of exercise 2.4. I hope you will understand it. If any difficulty, you can ask in Zoom meeting class. And in fourth part, if you want to check it, check it. The first one value supposed to y, the second one value supposed to u. And then by quotient rule, we apply the quotient rule on y with respect to x. We apply quotient rule because it is given in form of fraction. Here c is considered as coefficient, d and b are the constant. So when you simplify, you will get this. And then similarly, to differentiate with this u with respect to x, again you apply the the quotient rule. B and d is constant, a is the coefficient. So when you simplify, you will get this. After that, you apply chain rule on that. When you apply chain rule, you will get this answer. So I hope you will understand it. If any difficulty, you can ask in Zoom meeting class. Take care. Allah Hafiz.